Alright, so one thing that you learned in grade 10 that you certainly need to know now, and certainly going forward in grade 12 as well, is changing units. So quite often a question may list speeds in kilometers an hour. Often that has to be converted to meters per second. Do you remember what the rule is? Now let me just look ahead here. I have a funny, okay, so what's the rule for converting kilometers per hour to meters per second? Divide. So if you have a spot there, you should write down something like kilometers per hour to meters per second, you divide by 3.6. Kilometers per hour to meters per second, you divide by 3. Is it always going to be 3.6? That's the number, yeah. Okay, and the only thing you really have to remember is it divide or is it multiply? And the way I teach kids is, if it's big units, like kilometers and hours, bigger, big things, you got to make them smaller, like meters and seconds, then you have to make them smaller by dividing, right? And then the opposite is true. If you're going the other way, meters per second to kilometers per hour is going to be times by 3.6. Should that be a thing you've got in your cheat sheet for the next unit? Oh yeah. There'll be at least one or two people that forget to put it on there, and they're going to ask me during the test. And I'm going to say, well, you kind of got to know that. It's a test. It's kind of like getting in your car, going for your driver's license and saying, okay, which one is the brakes and which one is the gas again? They're not going to give you your license. You got to know. I guess you could try both. True enough. Hope for the best, yeah. You got a 50-50 chance. There's the other question there, but we already have that rule, right? Okay, so normally I am at this point sort of at the end of a class. I usually have I've usually gone through the test, or rather, and there's a few little minutes. So I'm not going to give you a lot of time to work on these, but you should know these. Define mechanics, kinematics, dynamics, translation of motion, write the formula for average speed, what is a frame of reference, give an example, and convert those meters per second, or those kilometers per hour to meters per second and vice versa. So basically all I've done there is highlighted the questions that are the important things in the thing we read, right? So when you do them or not is entirely up to you, but that's what you need to be able to do. So do them if you think you need to. Look at it, go, yeah, know that, yeah, good, we're done. Right? Any problems with any of that? All good? Okay. Let's begin with part 2. Now what I did here was, traditionally in the old days, this would have been a set of notes you guys write out, but I've given you like a fill-in-the-blank kind of version. So you have to fill in sort of the important things, and it gives me a framework to talk about a few things, right? So basically, what we were just talking about, part 2, kind of expanded a little bit here. So, linear kinematics. Kinematics is the description of motion by studying the relationships among the variables of position, velocity, and time. I think we defined kinematics before, basically as the description of motion, okay? So this is sort of an expanded definition by studying the relationships among the variables of position, velocity, and time. You've written down the definition for linear kinematics. Let's have a look at this little animation that's up on the board here. Obviously, you don't have it on your paper. Right? Right, Sam? Okay. Okay, so you can see a red car, a green car, and a blue car. Which one's traveling at a constant velocity? Maybe there's more than one.
They all are.
They all are?
Yeah.
Think so?
No, green slows down and speeds up. Blue speeds right up.
Isn't blue speeding up?
Yeah.
Very end, yeah.
How can you tell the blue's speeding up?
Or maybe red slowing down. Red slowing down.
Red slowing down? Well, green catches up. So either red is slowing down or green is speeding up. Right? A little hard to tell. What does constant velocity mean? Okay, ladies, these are the side conversations that need to stop. Okay, just because you're not writing something down doesn't mean you're not learning. You gotta listen. Okay? A lesson is designed to go in stages. Okay? If you don't get this, you can't move on. You gotta listen when I'm talking. What does constant velocity mean? Covering the same distance every second. Right? Covering the same distance every second. Which one of these has a greater, it says care, but which car has a greater average velocity? Why do you say the blue?
You know, there wasn't so much training.
Well, that's true. But the average, do they all go the same distance? Okay, they all go the same distance. Which one does it fastest?
The blue.
The blue one. So does that mean it has the greatest average velocity? Yes, it does, because it covers the same distance in the least amount of time. So which one would have the slowest?
Green, red. I don't know, it's tied.
It's a tie? Yeah, it does kind of look like a bit of a tie at the end, right? So I would agree. The red and the green have the same average velocity. One is speeding up, one is slowing down. Which car experiences the greatest acceleration? So what does acceleration mean?
Speeding up.
Which one has the greatest acceleration? The red.
Green. The green.
What?
Green. How does it caught up?
Well, the green has catching up to this. So it's got to be increasing, right? But the blue one gets.
Red has the fastest rate.
Yes, I think I would say the blue one does, right? It's tough to tell. Colin's right. The frame rate's a little bit deceiving. There's no one would help if there was marks on the help. If there was marks, I think so, right? You can sort of like count. You can see where they are. If you could pause it, would be really good. Okay, so these are the kind of things we're going to be talking about, just with displacement time, guys. Good morning, gentlemen. How are you guys? Oh,
Sounds good.
it's like Christmas, the three wise men.
We're missing the Queen Kahuna.
Okay, I will remind you that this is all review from grade 10. Okay, so I moved on to the next page. Okay. It says, the word motion implies movement from one place to another. You guys don't need to write this down, it's right there. Thus, position, where the object is located, is the most fundamental consideration in setting motion. In other words, you have to understand how to define, how to work with position before you can move with motion. Because motion is the change in position. So we start with position. And again, review from grade 10. In order to specify an object's position on a straight line, three things are required. You have them there?
Yeah.
You do. I don't have them on my page. They are an origin or frame of reference, right? Which is some arbitrary starting point. To define a position, you have to have a frame of reference. You have to have an origin. You have to say someplace like 6 meters from where? You know how when we did the vectors and I said you draw the reference line? The reference line is your frame of reference. Got it, right? So it's some arbitrary starting point. What does the word arbitrary mean? It just means chosen for no reason. There's no reason for it. It's just boom. There's the start point. Right? It's you guys use the word random to mean arbitrary.
Yeah.
That's teenage vernacular vocabulary. Usually we choose some point, call it 0, and that is the starting point, and we move on. We don't worry about why that is the starting point. Okay? So we choose some point, call it 0, and that's the starting point or the origin. When it's two-dimensional, it looks like that, right? I guess that would be better. Pretty tough to show 3 dimensions on a 2-dimensional surface. Usually we choose some point, call it 0, and that's the starting point origin. You guys are all familiar with, and then the order would be the x, and then the y, and then the z in that order, right? Okay? So to define position, you need to have something or some order. Okay, the second part of position is the distance. And what does distance mean? How far away the object is from the origin. Okay, to define position, you need the frame of reference and you need the distance from that frame of reference. How far away the object is from the origin. And it could be to the right, to the left, up, down, or some sort of, angle, right? And really, isn't that kind of what a vector is?
Yes, sir.
In fact, when we were talking about vectors, we are really talking about position, a position here, right? It's the same thing. Position is a vector quantity. And the last one is direction. Right? The last one is direction. On a straight line, positive and negative numbers are used to indicate direction. Positive to the right, negative to the left. All review. I'm hoping that this is nothing new for anyone. Right? Is there a way that you could summarize this sentence without having to write down every single letter?
No, you use arrow to the right.
Exactly. You don't need to write everything down, you guys. You've been trained to do that, I know. I need to untrain you. People don't do this in the real world. They just jot down. That's all you need.
You kind of get that in the question.
Big meanie. It's a skill, you guys. Note taking is a skill. Yeah, paraphrasing. Right. It just has to make sense to you. No one comes around and checks to see that you wrote everything down. Okay, moving on. The combination of these three things result in the object's position. That is, a position is how far away from a set point and in what direction. The combination of these two things results in the object position. That is, how far away from a set point and in what direction. Okay, so I have an example here. You guys have a number line right below, right? Okay, pretty straightforward, really, really simple. X1, just position 1, right? X1 is that? Plus 2. X2 is that? Yeah, see how easy it is? It's going to get harder. A whole lot harder, right? It's just review. Yeah. Okay. So, showing straight line motion. Okay? Again, we're going to be dealing with what's called straight line motion or rectilinear motion forward and backward, right? You could use what's called a position line. Consider the following trip, which is described in terms of position line. I've got a little animation here. You can do it on if you wish. There's the little ball. It goes like that. There's the +3. And then it comes back to -1. And I think there's, yeah, okay, there it is. Goes 3, and then back to -1. Did you notice that anything, not unusual, did anything significant happen during that little trip? Let's watch it again. No? Did you notice that it kind of paused for a little bit there at number 3? It did, didn't it? But when you've all drawn it all out at the end, can you tell that it paused? No. You cannot. Okay? So this type of thing, a position line, isn't a whole lot of good because it has no time. There is no time component there. It is useless. It's the last one you'll ever see. Okay? It helps answer the question, why do we have to do this? Well, because there's no time involved. So that's one reason. Okay, so let's move on. Now, you've seen position time graphs in grade 10. I know you have. If you had me, for sure, every other teacher in Manitoba is supposed to be teaching position time graphs. Okay? So, here's a position time graph for the same object motion. Now, actually, I lied a little bit. It's a little slightly different one, but I need to fix that, I guess. Can you tell what's going on here?
Yeah.
How long did the whole trip take, Grayson? How do you know? So does time always have to be on the x here, Riley, do you think?
Yeah.
It does. Time is always on the x. Position is over here, always on the y. What's the value of the slope? Let's look at the units. Meters per second. So the slope refers to the What do we measure in meters per second?
Slope.
Velocity or speed? Right, absolutely. Okay, so tell me, what is happening in the interval from 0 to 1 seconds?
3
What's happening from 0 to 1 seconds?
meters, 1.
Moving to the?
Right.
I'm positive too, Riley. It's moving positively or moving to the right to a position of +3. Do we know how fast it's going? You could do the slope. You sure could. What would be the speed? It goes from 0 to 3 in 1 second. So the speed would be that distance over time, 3 over 1, or 3 meters per second. Would it be a constant 3 meters per second? What is the shape of the graph when it's a constant 3 meters per second? Straight line. Straight line, exactly. So the slope of that line throughout that interval is 3, right? Okay, that's good. You guys remember all this stuff. Not sure why I was on pause there. Flat slope, stop. What happens in the interval 4 to 5 seconds? Is it still going left? Is that what you're saying? Yeah, still going left. Moves negatively or left to a position of -1. In fact, it goes past the original spot, the original orbit, right? It goes past it. What's the speed there? It goes from 1 to -1, so that's -2 all in 1 second, again -2 meters per second, right? If I do this, I take that slope and I put it there, it matches. Woo! Evil genius, Mr. Bennett. No? Genius or evil? Thank you. Okay, can you guys answer those? I think that's the last thing we got to do, right? I'm going to have to go find that vegan video to show you.
Vegan.
Vegan, yeah, that's what I said.
Vegan. Oh.
Okay, you guys try those. Okay, so what does a positive slope line mean? Guys, stay with me for like 3 minutes here, okay? Positive slope line means motion to the right, positive direction, motion to the right. If it's a straight line, it means constant speed. Straight line means constant speed. A zero line or zero flat slope is no motion, stopped. And negative slope simply means going to the left, right? I just taught you everything from grade 10 in about half an hour. Why did it take so long in grade 10? New, right? You're a little older, you're a little wiser. Some of you.